Assalamu alaikum.
Walaikum Assalam.
First of all, a warm welcome to you all in this webinar presented by IEEE Robotics and Automation Society, CUIBA. And today we have our speaker, Engineer Muhammad Furqan, with us. He is researcher in Queensland University of Technology, Brisbane, Australia, and former satellite communication specialist, Ministry of Defence, Qatar, and also served as senior executive VSAT DVB Wateen Telecom, Pakistan. And today he will talk about lower Earth orbit high throughput satellites, Mega-Constellations. And there are some rules for attending this webinar. For our attendees, kindly make sure that their mic is muted, and there is a question answer session held at the end, and our speaker will answer all of your queries. So, Mr. Muhammad Furqan, the platform is all yours.
Thank you. Thank you very much. Bismillahirrahmanirrahim. Assalamu alaikum, ladies and gentlemen. I'm really honored for being here with you guys and interacting with the students, especially from Pakistan, is one of my favorite activities. I have been in touch with a lot of students who have been graduating and who are studying, and guiding them for their career and for their studies is one of my priorities, because Dr. Aves knows that we were not very good at studies, so we want you guys to learn from our mistakes. So let's begin, and then we can have, I will take your question answers in the end. So I have just kept the presentation very simple, just to give you an idea how things work. Can you guys see the presentation now?
Yes, sir.
Okay. So let's begin. This I will give you the introduction about what LEO HTS. Generally, we call it LEO HTS. It's low Earth orbit high throughput satellites. What are they and how they are? What is the introduction about them? What are the mega constellations? Which technology will be used? And throughout this presentation, it's a very general presentation. I made it just to give you an idea, but I will try to be explain it in details, everything that's come across, and later we can have a discussion. So low Earth orbit high throughput satellite. So everything is mentioned in the name. Normally, we used to communicate through geo satellites, which you can say geostationary satellites. Geostationary satellites are the satellites which are aligned along the equator, and they are at an altitude of 37,000 kilometers. So 37,000 kilometers is a very big distance if you start calculating. All of you are engineers. So these satellites were known as geostationary satellites because they were stationary, they were not moving, they were there in a fixed position, whatever the position was allocated to them from International Telecommunication Union, ITU. I hope you all understand what ITU works for. It is basically responsible for all the radio frequencies and satellite communications and all the terrestrial communication globally. It's a part of United Nations. So when we talk about geostationary satellites, so the orbit is known as geosynchronous orbit, and the satellites are geostationary, and they were fixed satellites. If you happen to if you are watching on a TV channel, and you will be having some information below in the tickers that our channel has moved to new satellite. This is the frequency range, this is the polarization, this is its orbital position. So normally you might have heard the name of AsiaSat or PathSat. So these satellites were basically used for broadcast communication, but they were also used for telecommunication, from backhaul communication. Backhaul means that it is not communicating directly to the end user, it's communicating to the access point. Or you can say the BTS in case of cellular communication, which cannot be connected to the BSc or MSc through fiber optic or microwave. There are regions where we don't have microwave transmission, or we don't have fiber optic transmission, like remote areas in northern Pakistan, or very isolated, limited population, small areas, like say we have a lot of such populations in Balochistan. Laying a fiber cable to that location, which has a very small population, it's not very viable. I was working in Wateen Telecom, as the host explained in my introduction. Our main purpose of business was provide VSAT, very small aperture terminal services to cellular operators like Warid, Warid or Mobilink. These satellites were used to relay the signals on the physical layer, if you're talking about OSI model. They used to bounce back signal from BSC to the remote BTS, and two-way communication was established. There is just to give you an idea that the lower Earth orbit, there are basically three kind of orbits. Geostationary orbit is the highest one. Then we have medium Earth orbit. There are a few satellites in medium Earth orbit, like the satellites we use for our positioning system, like GPS or navigation. It is known as basically GNSS, Global Navigation Satellite System. It is used for our positioning and time. The time which we normally have on our cell phone, or we have on the TV channels for the news broadcast, from which we establish the standard time and we synchronize our clocks. They are basically satellite time. They are basically generated by the positioning satellites. That is the most accurate time. So satellites are not only used for communication, they are used for so many purposes. When we are talking about the lower Earth orbit, it's not really defined like the geostationary satellites is 37,000 kilometers. So lower Earth orbit is somewhere between 800 to 2,000 kilometers altitude. Again, I'm talking about kilometers, not feet or meter. The SpaceX, I believe that all of you know what SpaceX is, that Elon Musk is doing with SpaceX. It's not only providing launching services to NASA or providing logistic services to International Space Station. SpaceX has entered into the satellite communication market with a huge mega-constellation for its low Earth orbit high-throughput satellites. And they have introduced a new orbit as well, which is known as VLEO, or Very Low Earth Orbit, and the satellites will be around 350 kilometers in altitude. So they are going to be very near to the Earth. Then these satellites are non-stationary, and they will be moving at a velocity of 9 kilometers per second. So imagine a BTS moving at 9 kilometers per second. And whatever mobility you are using, you are driving a car, say, even if you are driving at 200 kilometers per hour, or you are flying, we now have in-flight connectivity for Wi-Fi and mobile communication. Whatever mode of transportation you are using, so you are practically stationary as compared to the BTS, which you will be connected through. So 9 kilometers per second, it's humongous. And now, if we talk about comparison to the lifespan, the geostationary satellites normally lasted for 15 years. This is not the life of the geostationary satellite itself. It was basically the life of the battery banks which were used to store the power. If you have seen satellites in any images, or mostly in movies, especially in the English movies, the bad guys, they have to do something. They have to destroy the Earth. At the end of the movie, they use satellites to generate some kind of virus or hack the whole banking system of the world. So you might have seen the satellite. So the two wings which we normally see, the satellite has, it is basically the solar panel, which is used to generate electric power for the satellite, and it is stored in a battery bank on board the satellite. So these 15 years of life for geostationary satellite is for the battery bank. After 15 years, the battery bank starts dying out. So that's why we consider the life of a geostationary satellite as 15 years. It is a good project if you guys are looking for your project or further research or going for masters or PhD, that how can we uh, uh, make the make the most of or we how can we deploy better batteries and prolong the life of geostationary satellite. So as compared to that, the low Earth orbit satellites, they will be moving 9 kilometers per second. So their life will be around 3 years. And after 3 years, they have to be replaced by the next satellite. Primarily because the geostationary satellites, they are stationary, they are fixed in a position. So most of the electric power is consumed for communication purposes only. And for lower Earth orbit satellites, they have to constantly move. So they have to utilize the power for that as well. So that's why their life is very less compared to the geostationary satellites. And another important thing about this, if you are comparing these satellites, is the latency. Latency is the delay of transmission, which we used to have for geostationary satellite was 240 to 280 milliseconds for one-way trip, and for round trip, it's well above 530 milliseconds. It means that all the new technology, the Industry 4.0, 5G, or even if you're talking about 4G LTE and its applications, some mission critical applications like vehicle to vehicle communication, or let's say uh, remote health services, rescue and rescue operations, and applications of high throughput communication satellites. So this latency was a very, very big problem, that we are talking about 530 millisecond round trip. And so many applications get out of sync and they do not respond as they should. And basically they are developed keeping in mind the latency of fiber optics, or the latency of mobile communication. So 530 milliseconds is a huge amount, and it cannot be reduced because we are talking about 37,000 kilometers altitude. So you do the math. You take the speed of light and you calculate the distance for the round trip, how much time it's going to take. So it's not very difficult to calculate. But you cannot do anything about the orbit of the geostationary satellite. It has to be 37,000 kilometers. The big point about geostationary satellite is that one satellite can cover up till 1/3 of the globe. So if you start moving away from any object, like if you're taking a photograph, if you all of you will be having habits of taking selfies. If the camera is too close, it's not really good. So you have to get to an optimum distance to get your perfect picture. So that's the reason that if you go further away from the Earth, we get more coverage of the area. And if you move closer, we get smaller areas. So that's why low Earth orbit satellites have very small coverage areas compared to geostationary satellite. But again, we are talking about the data latency. For LEO satellites, it will be around 40 milliseconds. So we are talking about latency of at par with 4G LTE, or even with the fiber optic communication. So that's why we are talking about mega-constellation, because they are very close to Earth. So a lot of satellites will be required to cover the whole globe. And we can increase the number to increase the throughput as well. More number of satellites, more data throughput. To meet this is what to talk about mega-constellations. So I was talking about SpaceX earlier. SpaceX, Elon Musk, everybody knows, he's coming with the constellation known as Starlink. It is going to be 42,000 satellites to provide global broadband service all over the world, and they will be using frequency band Ka, Ku, and V band. Actually, the time is limited, so I could have gone into the details of these frequency bands as well, but it's not very difficult. You guys can have a look, or you can Google it, that what Ka band is, what Ku band is, what V band is. And these are basically frequency bands. Again, these are allocated by International Telecommunication Union, and there are some frequency, radio frequency, it is limited. We have 300 kilohertz to 3 kilohertz to 300 gigahertz. That's all the radio frequencies we have, and we have to live in it. And if you know the 5G new radio, it's known as 5G new radio because it is going to use a lot of new radio frequencies as compared to the previous or its predecessors up till 4G. They were using up till 3.6 gigahertz. So 5G is going to be using a lot of new frequencies as well. So we are going to into the scarcity of the spectrum. Then we have Boeing. Everybody knows Boeing, and they are basically when we talk about Boeing, everybody thinks that they manufacture aircrafts, passenger aircraft. So Boeing is a big company. They manufacture everything from satellites up to military aircrafts and helicopters, and they are into data security, communication, and they are coming up with 3,300 satellites. And Kuiper System, Amazon, Jeff Bezos, another multimillionaire, billionaire. I think he's a trillionaire. No, billionaire. So this is a competition. It's a healthy competition between the billionaires. So he came into the market as well to support his Amazon Web Services. And initially, he has filed for about 3,200 satellites for his Amazon Web Services to provide global broadband. But this number is going to be revised because if we talk about Starlink of Elon Musk, he initially filed for 4,000 satellites with Federal Communication Commission, FCC. It's like PTA of USA. So ITU and FCC, if you get approval from these organizations, you are pretty much okay to operate anywhere in the world. So initially he started with 4,000. He revised the satellite number of satellites to 12,000, and now he has come up with 42,000. So the first application which Jeff Bezos filed was for 3,200 satellites, and it is likely going to be revised because he's going to compete. Because it's not only Amazon he is owning; he also owns Blue Origin. If you guys have heard, it's just like SpaceX. It provides launching services to NASA and other space exploration organizations. So he is into space already, and he's coming into satellite communications as well. Then we have a player known as OneWeb. Actually, all this Leo Mega-Constellation game was started by OneWeb. It was basically started by Virgin Group. If you know, again, another superstar billionaire, Richard Branson. He has a lot of airlines: Virgin Atlantic, Virgin Australia, Virgin US, and Virgin Music. So it's a big group. Then we have Qualcomm. Qualcomm is the company which manufactures the processor of every smartphone. I hope you guys know it. And Airbus was manufacturing this satellite. Airbus, just like Boeing, it's European. Boeing is American. Airbus is a European brand which manufactures aircrafts, not only aircrafts, military aircrafts, helicopters, and satellites, everything. It's a huge company. So it started with that, and they were basically starting with 750 satellites, and they increased the number up till 1,900. And they were basically relying on, if you see in the services recovered from Chapter 11 bankruptcy, they were basically looking for financing from SoftBank. SoftBank is a big group in Japan. SoftBank is also a mobile operator, and it's a investment group as well. So they were basically looking for investment from SoftBank, and by the time COVID-19 hit, SoftBank decided not to invest in OneWeb. So they applied for Chapter 11 bankruptcy. So many jobs were lost. And later, they recovered from bankruptcy, and they filed for 48,000 satellites from just 1,900. And 48,000 satellites, it was a big number, and everybody was shocked that who is the investor is. So practically what happened is that it is a 50-50 game. 50% investment is from a very huge investment firm from India. Bharti Airtel Group, I think, Bharti Airtel Group is 50%, and 50% is invested directly by the Queen of United Kingdom. It is known as Her Majesty Government UK, HMG UK. I'm not talking about the federal government of UK or their communication, Ministry of Communication or Ministry of Defense, directly invested from the Queen. So that is why it is this is becoming really interesting, because all the billionaires and there was a rumor that the Crown Prince of Saudi Arabia, Mohammed bin Salman, has also got some investment in here, but it's still a rumor. We cannot verify it. Maybe if we get some Panama leak, some hack kind of thing, then we can get the idea who the real investors are. Maybe a lot of from Pakistan as well. So there are some other small players which are coming for these small number of satellites which are coming. They have very specific purposes. They are not for global broadband or other you can say internet or mobile communication services. So they are very specific for their purposes. Now, what the technology is, it is basically data related to unserved, underserved mobile users, connecting them to the internet. Or basically, the concept was started by Google. There was a company established by Google. If you go back a few years ago, it was known as O3B. O3B stands for Other 3 Billion, because there are half of the population on Earth does not have access to internet. So Google started that project, O3B, Other 3 Billion, to provide internet services to the people who do not have access to the internet. And they were basically coming into the medium Earth orbit, and it's about more than 2,000 kilometer altitude. The project was a failure. The satellites are there; they were launched, but Google stepped back from investment, and the project was prone to collapse. But there is a big satellite operator from Europe, SES. SES Satellites invested in O3B and recovered it, but it still is not a successful project. It does not have any clients. So the 3 billion population is a huge amount, and that's why these billionaires, they're not going to serve the humanity. They're just coming up for because of a business case, and for the business case they are using the technology. And by technology it means that everything that is accessible to you and me sitting in a comfortable city. We have the internet, we have all based on internet, we have so many other things that we are enjoying as a luxury. It has become a necessity for us, all those things, and it may be the luxury for other 3 billion. But imagine that if the internet is provided to those on 3 billion people, with that, it's not only about internet. So many applications can be provided to them, and a lot of business can be generated from it. We are talking about education, we are talking about health, we are talking about government, we are talking so many things. And serving the broadband on global scale, I think by now we have the idea how this thing is going to work. Then the most important thing is the portable user terminals with plug-and-play features. When I'm talking about this, when we talk about traditional satellite communication, you guys have seen satellite antennas, dish antennas. Not about the one we have for the TV channels we used to have in a couple of decades ago. If you talk about communication infrastructure, if you see, you might have seen some wide kind of dish antennas which are available for communication. It required a lot of expenditure, capex and opex, and a lot of technical skills to install those antennas. And they have to be very accurate in their installation. They have to be looking at the specific satellite for providing seamless communication. There have to be accuracy. So technical skills were required for installation. A lot of expenses were required. If I'm talking about a very small antenna, let's say 1.2 meter antenna, diameter antenna, how much it used to cost? It was more than ₹1 million. I'm talking about when I was working in the industry. So more than 10 years ago, so ₹1 million. So it is going, these constellation they will be having, because they are very close to Earth. So no need for big antennas, fixed antennas. no need for endurance installation. So they have portable terminals. You can plug and play. You can no need for any skilled you can say labor or technical skills required for those installations. And they will be using a lot of frequencies from ITU allocated spectrum. Previously, satellite communication was using C band, L band, and KU band. Now, K band, Ka band, and V band, and up to Q band will be also introduced soon because there is a competition going on between mobile operators and satellite operators for the. It's kind of a war. If you ask me, the International Telecommunication Union conducts World Radio Congress every 4 years, where they decide the spectrum and how to be allocated. All the members of the United Nations countries attend that. From on behalf of Pakistan, PTA goes there. Then mobile operators who are the member of ITU, they go there, and then the vendors who manufacture the network equipment like Ericsson, Huawei, and those attend that. Investment firms. So it's kind of a really uh, ongoing battle for the spectrum. It is kind of, you can say, a scarce thing, just like any rare earth element. It is getting rare to get a lot of frequencies. Everybody is using all the influence on all the money they can. So a mobile operator has the 5G in particular have taken a lot of frequency from satellite operators. So there is lot of you can work on that as well if you are looking for your final year projects or you're looking for higher studies. The radio frequency spectrum is just like it's going to be just like we are talking about cryptocurrencies. It is going to be a currency of the future. So but on not on individual scale, on a state level or at a corporate level. So how we are going to integrate this technology into existing infrastructure is that it is not a competitor to fiber optics or mobile operators. It is going to complement it. Just like you guys experience a lot of network outages and you contact PTCL or Miatel and you ask if there's an outage or the internet is slow. Every time they say, oh, the CME V4 or CME V5 fiber optic cable in the marine cable has been bitten by shark. So that's why we are losing bits and bytes. We are leaking them in the water. We are polluting the water with the bits and bytes. So these satellites are basically going to complement those marine cables, and it is they will complement, just as I said that we were used to provide services for mobile operators in remote areas. So they are basically going to complement them for underserved and unserved areas. It's not a competition, and by competition I mean it's very highly unlikely that for example, if you're talking about ourselves, we have fiber at our home. It's really highly unlikely that we install a satellite terminal as well for connectivity. It is for the regions or areas where it's impossible to provide services through conventional methods. And providing the backhaul and front haul interface service to terrestrial network operators. I guess you guys have an idea of the interfaces. Like backhaul and front haul. Front haul satellite communication was not providing traditionally. Only there were two services which were providing front haul services. If you guys have heard of Thoraya, it's a UAE-based company. It is basically a Suraya. If you in Arabic or Urdu, the word is Suraya. It's a constellation of stars. And so, if we translate it from Arabic to English, or we pronounce it from Arabic, so it became a Thuraya. So Thuraya was providing front haul services, and there was another company, American company, Iridium. It was providing front haul services, but it was very expensive, and it was just for voice. Data services were providing just like an SMS, and it was very expensive. So if you're talking about these satellites, so they will be providing, because obviously they are very close to Earth. just to let you know that the Thuraya and Iridium, they were using L-band frequencies, which are very low frequencies as compared to Ku or Ka band. So that's why it's possible for a geostationary satellite at 37,000 kilometers to communicate with a person for a handheld device without any big dish antenna. So if we're talking about higher frequencies, we used to have big antennas for communication. But when we are talking about lower orbit satellites, the front haul is pretty much possible. But it has not been implemented yet. They have just started with the backhaul services. They have just started. And just to let you know that the SpaceX and OneWeb, they already have satellites in the orbit. SpaceX has about 480 satellites at the moment, and OneWeb has about 60 satellites in the moment. And now they are, if you follow the news, every other week, SpaceX has a launch, and it's launching 60 satellites per launch. So it will take a time to achieve the number of 42,000, and OneWeb will definitely need some time to go to 48,000. So the satellites are there, the numbers are there. They have started providing test service in the United States, and the results are really good. They are achieving 100 Mbps, and the latency is up to 36 milliseconds. So 100 Mbps through satellites, it's amazing, because when we are talking about traditional satellites, we cannot have even a single transponder that can accommodate that much amount of traffic or that much amount of data throughput. So even if you're talking about spectral efficiency, so the spectral efficiency, amazing. I'm not comparing it with the 4G LTE or 5G. I'm comparing it with the traditional satellite communication. So, increasing subscriber base of the traditional network by unserved and underserved areas. This is what I talked earlier, that this is the business case. This is the real business case, that you are getting 3 billion customers, and this, through those 3 billion, you are getting so many. So you are going to provide them so many services. Imagine a person who is starving in the middle of Sahara Desert, and he cannot get water or food or medicine, but he will be able to stream Netflix uninterrupted. Amazing. So the applications, these constellation will have mobile broadband, remote communities, and then we have government, aerospace, and defense. This one is of really pretty good, pretty interesting thing, that aerospace and defense. If you guys have followed the recent news, United States recently announced their space command. That's the fourth element of their military infrastructure, space command. So if you're talking about warfare, there are 5 dimensions to that. First dimension is the land, because the first war started on land. Then the second dimension is the sea, because later the humanity discovered the ship, invented the ships, and then we started having fights, and we established navies. The third dimension started from World War I, that is air. The air forces were established. The fourth dimension is space. Everything is going in space, and if you follow the news, you might have seen that Russia, China, and India, they have tested anti-satellite missiles, and they have destroyed their own expired satellites in the orbit using their own missile systems. And it's not only limited to the satellite communication, the space dimension of the warfare, the fourth dimension. It's going beyond, like the moon, colonization of moon, or colonization of Mars, and beyond our solar system or beyond our galaxy. So every country is going to invest in that. And the fifth dimension of warfare is the cyber warfare, which we normally misinterpret as 5th generation warfare. You might have seen so many press conferences on local media, this calling it the 5th generation warfare. It's not 5th generation warfare, it's 5th dimension. So these satellites are basically going to be play a very vital role in the 4th and 5th dimension of warfare. And again, satellite communication has always been used for oil and gas and mining, because these infrastructure are not near any human settlements. They are in deserts. They are in the deep sea. So they rely totally on satellite communication for their communication of. And when we are talking about Internet of Things, the 4th industrial revolution, automation and artificial intelligence and robotics, here in Australia, a lot of things have, because Australia's economy rely mostly on agriculture and mining, and they have been conducting tests for artificial intelligence for their equipment, mining equipment, and automation of all that thing and controlling it through some metropolitan area using satellites or using wireless communication to serve the purpose. And because it's automation is just there to reduce the cost, the biggest cost is our human employees. They work 8 hours a day hardly, and all unlike in Pakistan, in these countries they have very strict labor laws. You cannot let any labor work more than 8 hours, and they become very costly, and they get sick, they have families. So automation is a good business case. Just as I discussed earlier, the billionaires, they want business. So similarly, these oil and gas and mining companies, they want business. They don't want to waste so much amount on human resources. So automation is a win-win situation for everyone. And obviously there is a lot of joblessness for engineers. I'm not discouraging you. I'm just giving you an insight. What's because technology is, as they say in French, frisson. Frisson means something that is really exciting and something that is really fearful at the same time. So hope for the best and prepare for the worst. And again, I'm talking about environment, earth and marine observation, animal migration observations, and then we have broadcast. We have HD at the moment. Then we are looking forward for Ultra HD broadcast. They were taking place through satellite. Now we are moving to 8K to 12K resolution. Then obviously a time will come that we will be having 3D TV at our home. Most of the TV channels, especially the sports or National Geographic or Discovery, there or the movies channel or the cartoons channel, they will be coming in 3D format, and our household television will be supporting that. And to accommodate that, they need a huge amount of data, and for that, the spectrum scarcity, as I discussed earlier. So that is going to be a big problem again. Then we have mobility, logistics, maritime transportation, plane management, and in-flight services using your internet over the flight. And then we, as I discussed in Australia, agricultural technology, livestock, and health and education. And as if you're talking about agriculture technology, you guys, if you're looking forward for some good opportunities in the future that you want to explore, because back in our days when we were about to graduate, we were looking for jobs. And now I have an idea that most of the graduates, they are looking to explore startups. They want to be an entrepreneur. They're getting a job or going for higher studies is their second priority. First priority is getting a startup or starting up their own business. They have really good ideas, and but 99% of the startups end up in failure because they have good ideas. The students, they are very energetic, they are young, they have good ideas, but they don't have they have some financial issues, or they do not have any experience about business or business modeling or business planning, business case, registrations, regulation, policies. So because of those loopholes, it's not a failure, it's a learning. Eventually, I have learned about 23 to 24 times. I have started 23, 24 startups, and I have learned. I have never succeeded in any of them. But if you're talking about some scalable startup, I would recommend going for agricultural technology, because Pakistan is an agricultural country and 70% of the population and 70% of our economy depends on agriculture. But what the problem is that, especially the people living in city, they are all going for outsourcing kind of project, that we get an outsourced project from US, or Elon Musk will directly give us a project and we will work on that and we will become successful overnight. So this not that is possible if you say in some if you talk about probability, very low probability for that. But go for something that is related to agriculture. Agriculture technology is the future, and especially for Pakistani market. You, if you have some good ideas, then you can work and you can. It's an idea, just a suggestion. Not all of you start doing that. I'm just suggesting. Then the possibilities, lower latency, global coverage, high throughput, we discuss all that, utilization in industrial 4.0 use cases at par with 4G LTE services, because I told you the latency is 36 milliseconds, so LTE is giving us about 40 milliseconds, and data rate, we can manage that. 100 Mbps is good so far. And onboard processing for software-defined radios and software-defined networks. This is another good area to explore for your future, the software-defined radios and software-defined networks. What is happening is that we are not using any hardware. We are using just the processors to perform this, functioning of the radios and networks, like the first 3 layers of the OSI model. We can manage through processors. We do not need any additional hardware like switches or routers. And in 5G, they are known as NFV, Network Function Virtualization. There are so many terminologies used for that. And then it is going to have smaller and portable user terminals with no technical training required. So it can be transported anywhere, and you can communicate anywhere you want. And if you guys are love adventure and you go for hiking or trekking, I think Dr. Aves is a very adventure-loving person, and he is most of the time on his bike, and he's going to the places I could not imagine going without a SUV. So you can have a terminal with you, and you can upload your pictures instantly from Facebook or Instagram. So reduce capital expenditure and operational expenditure for service provisioning. And fourth and fifth dimension warfare, as I discussed earlier. Then we have Space Race 2.0. So this is the Space Race 2.0. The Space Race, first Space Race started in the 50s during the Cold War. And basically this satellite communication is the brainchild of Sir Arthur C. Clarke. He gave the idea in 1945 that if we have 3 satellites placed at 37,000 kilometer altitude, then we can cover the whole Earth and we can provide communication services. So it was the brainchild. He is basically a science fiction writer. He's passed away. He was a science fiction writer. He was not a scientist or not an engineer, but he was a science fiction writer. And he had a very good movie, I think, 2001: A Space Odyssey, one of the best movies to watch if you are a space enthusiast. So it was his brainchild, satellite communication, and from that idea, space race started between the Soviet Union and the Americans. And the space race one was basically for the supremacy of the government of two poles that we were having in the Cold War. But space race 2.0, it's totally commercial, and billionaires are basically competing with each other. And just to let you know that Huawei also announced to come into the race for this satellite communication, low Earth orbit. I remember when I was in Beijing in 2010, we had a meeting with Huawei, and I asked them that Huawei is a mobile communication, and they have been providing services for mobile services, but it's not investing in satellite. And they said that we do not want to invest in satellite because that only 2% of transmission of the world is controlled through satellite. 98% is through microwave and fiber. So we don't want to waste our investment in satellite communication. But now the times have changed. So Huawei definitely is going to the race. There are a lot of opportunities you can explore. There are some challenges which you can work on for your higher studies or your pioneer projects, even your startups. First is the regulatory, because different countries and these satellites will be flying over the globe. They will be flying over every country, so there will be a lot of regulatory related issues. That are they allowed to fly over their territory, or are they allowed to transmit when they are flying over their territory? One is the case of air traffic management, and one is the case of radio frequencies. Then space situational awareness. This is a very, if you opt for higher studies in space engineering, space situational awareness is just like our pedestrian awareness or our vehicle awareness kind of thing. Like there was an incident because about 100,000 satellites are coming up, and they can create a lot of hazards, space debris, or they can collide with each other, and they can so many disasters can happen. This happened last year. There was a satellite of Starlink, SpaceX. Elon Musk's satellite was going in one direction, and there was a satellite of Earth observation from European Space Agency, ESA. It's just like NASA for Europe, ESA. And the satellite, they were both coming in each other's way. And the European Space Agency, it's a very old agency, just like NASA. It's a huge agency. They contacted SpaceX and they asked them to move their satellite. Otherwise, they are going to collide. And SpaceX said, no, you have to move your satellite. We are not moving our satellite. Americans have the right of way. So the Europeans had to move their satellite to avoid the collision. Americans they were not bothered at all because they already are planning 48,000 satellite. Losing one won't hurt them. But European Space Agency had a very expensive satellite which were observing our Earth environmental issues. So it's not a business satellite. So then we have radio frequency congestion. I talked about a lot of times, and then we have cybersecurity because so many things, Internet of Things, agriculture technology, mining, everything will be coming to the grid. 3 billion more customer coming to the grid. So there will be a lot of cybersecurity challenge. And if you are interested in going exploring new options for your career or your higher studies, cybersecurity is one of them. And it is going to be very essential, one of the most essential career in the future. If you go to the Forbes and look for the top 20 professional careers in the next 20 years, cybersecurity is one of at the top. So this is how things are going to unfold. And this is me. This is my details, my LinkedIn, my website. It's not updated, so don't visit it, please. And my LinkedIn is, I'm really working on LinkedIn. You can contact me and my Twitter as well. And these are my expertise, not expertise. I have learned a few things from these areas. So that is me, and thank you for your patience and listening to me for 1 hour. I really apologize if I hurt anybody's feeling. I hope my talk made sense. Thank you. Is there any question? Any moderator?
Mohsen, you can ask.
Assalamu alaikum, sir.
Waalaikum
Sir, that we have seen Pakistan is using technologies, mobile technology, especially satellites from America. Now we are transferring towards China. How you see that Pakistan is going to develop their own technology and own satellites in the future? What will be the first step?
Developing a satellite is not expensive. There is a student from India. His name is Rifat Sharouk. I know him personally. He developed a satellite of 9 kg and he launched it last year, but it lasted for a few hours. Then it collapsed. So manufacturing a satellite at a very small scale is not an expensive cost. And if you're talking about our previous satellite, ParkSat-1 was American. It was an expired satellite from Intelsat, and we purchased it from them just to fill our orbit. Its replacement, ParkSat-1R, it is made from China. I think it was developed by the Great Wall Heavy Industries. It was launched by China. It was then later on, its operations were handed over to Pakistan. So if you're talking about strategic satellite, let's like ParkSat-1R, it's a huge satellite, and we are talking about geostationary satellite. It's serving the purpose of our government requirements, as well as it is serving our broadcast channels. So that kind of satellite, it's a difficult task. it takes time. If you search for geostationary satellite development, it takes about a year to develop such a satellite. And if you're talking about the lower satellites, which the presentation was about, it is mass production. Just like any Ford car assembly plant, it is produced massively, assembly line production. So if we have to get into that kind of thing, I think it's virtually impossible with the economy of our country, or we do not have, just like if I was talking about Elon Musk or Jeff Bezos or the Indian investor, I think his name is Sunil Mittal. Yeah, he invested in OneWeb. Most of the Indian investors are moving towards technology like Tata Consultancy Group and Tech Mahindra. But our billionaires, they are into property and these kind of stuff. So we do not have any commercial aspects to those satellite communication. We do not have any government interest into that. And we do not have, actually our growth is very slow in space sector. Even if you're talking about support from the government, it is very slow process. It is kind of ignored area. So you may take an opportunity and present to the concerning people through your university. Definitely, you can work on an FIP or a thesis where you can identify the challenges, why we are not progressing like that, and what are the hurdles, how can we overcome those challenges.
Thank you, sir.
Any other questions?
Yes, Tahir, you can ask.
सर ये पूछना था आपसे कि सर ये जो कॉन्सेप्ट है एलन मस्क का लोअर ऑर्बिट कम्युनिकेशन वाला, सर इसमें या जो अभी जिस सेमिनार आपने दिया, सर इसमें हमारा साइबर सिक्योरिटी का इशू बनेगा या नहीं बनेगा? क्योंकि सर वो तो क्लेम कर रहे हैं कि हम लोग बगैर किसी फिल्टर के, बगैर किसी मतलब आपके जो कंट्री के जो सिक्योरिटी होगी उसको मतलब वो उस पर बैन नहीं लगा सकेंगे, उसको फिल्टर नहीं कर सकते। तो क्या ये प्रॉब्लम होगा कंट्री के लिए?
सैटेलाइट कम्युनिकेशन में तो ऑब्वियसली आप कोई किसी को रोक नहीं सकते, क्योंकि सैटेलाइट बेसिकली आपके, अभी हम जो नॉर्मल फाइबर ऑप्टिक की बात करते हैं, जो आपके गेटवेज हैं, जो कि आपके पीटीसीएल के थ्रू या आपके एयरटेल के थ्रू या किसी भी डाटा सर्विस प्रोवाइडर के थ्रू जो आपको सर्विसेज मिल रही होती हैं, वो आप गेटवे के थ्रू आ रही होती हैं। गेटवे के ऊपर चेक एंड बैलेंस पीटीए लगा सकती है, गवर्नमेंट लगा सकती है, मिलिट्री लगा सकती है। लेकिन सैटेलाइट बेसिकली आपकी अपना एसेट नहीं होता। सैटेलाइट इज बेसिकली इन द स्पेस, और अगर आपके पास टर्मिनल है आप उससे कम्युनिकेट कर सकते हैं। वो आइडेंटिफाई हो सकता है कि कौन सा टर्मिनल किस लोकेशन से कम्युनिकेट कर रहा है, तो यू कैन बी ट्रैक्ड। बट ऑब्वियसली इट्स कमर्शियल प्रोजेक्ट, तो डेफिनेट सी बात है अगर उन्होंने सर्विस, पाकिस्तान की 25 करोड़ की आबादी है, तो डेफिनेट सी बात है कि सो मेनी कंपनीज विल बी हैप्पी टू गेट देयर सर्विसेज, और डेफिनेटली उसके लिए वो गवर्नमेंट से अप्रूवल लेंगे, लाइसेंसेस लेंगे। जिस तरह 4G 5G के लाइसेंसेस ऑप्शन होते हैं, या जिस तरह स्पेक्ट्रम के लोकेशन होती है पीटी की तरफ से, तो डेफिनेटली इन सर्विसेज के लिए भी ऑप्शन होगी, और कोई ना कोई सर्विस प्रोवाइडर जो है ग्राउंड के ऊपर उसकी सर्विसेज प्रोवाइड करेगा। और इसमें नॉर्मली यही आपके जो मोबाइल ऑपरेटर्स हैं यही इसके लाइसेंस लेंगे, होपफुली, या आपके जो इंटरनेट सर्विस प्रोवाइडर्स हैं, ISPs हैं, तो वो ही इन्हीं के लाइसेंस लेके आपको सर्विसेज प्रोवाइड करेंगे। तो इनके टर्मिनल्स बेसिकली अगेन जैसे IMEI वाला कंसेप्ट होता है या सिम का कंसेप्ट होता है, तो टर्मिनल ऑफ द शेल्फ नहीं मिल सकते आपको। इट्स अगर आपने परचेज करके कम्युनिकेट करना है, दे आर ट्रेसेबल। तो वो एक एंड से तो साइबर सिक्योरिटी का इशू, दूसरी एंड पे साइबर सिक्योरिटी का इशू उस तरीके से हो सकता है अगर आप उसको लीगली परचेज भी करते हो, आप अपने उसके लिए फॉर एग्जांपल आप किसी सर्विस प्रोवाइडर के थ्रू सर्विसेज परचेज भी कर लेते हो आप, लेकिन आप उसको यूज कर रहे हो बेसिकली वो एक्सेस पॉइंट है, और आपका आगे होम का नेटवर्क या आपका जो बिजनेस का नेटवर्क है या आपके जो इंडस्ट्री का नेटवर्क है, जो आपने IoT आप यूज कर रहे हो या आप अपने डिवाइसेस यूज कर रहे हो, तो दे आर एक्सेसिबल, जो कि गेटवे के बाईपास होके एक्सेसिबल हैं। तो कोई भी इंट्रूडर आपके इनको एक्सेस करके उसके अंदर वो आपके लिए प्रॉब्लम क्रिएट कर सकते हैं। सो जो साइबर सिक्योरिटी का प्रॉब्लम है दैट गोज बोथ वेज। लेकिन डेफिनेट सी बात है कि इसमें इतनी इन्वेस्टमेंट हो रही है और इसमें इतनी ज़्यादा पार्टीज इन्वॉल्व हैं और इतने ज़्यादा हाई स्किल्ड लोग इसके अंदर पार्टिसिपेट कर रहे हैं। तो बट स्टिल व्हेन देयर इज टेक्नोलॉजी देयर इज ऑलवेज वे आउट। तो ये साइबर सिक्योरिटी के चैलेंजेस होंगे, बहुत ज़्यादा होंगे।
सर अगर सर इंडिविजुअली अगर कोई बंदा करना चाहे, मतलब अगर वो कोई इन्वेस्टर है, वो इन्वेस्ट करता है और मतलब आपको ग्लोबल लेवल पे एक्सेस मिल जाती है, लेकिन कंट्री लेवल पे वो आपको अलाउ ही नहीं करते कि भाई आप हमारी सर्विसेज लॉन्च करो, तो सर वो क्या उसके लिए मतलब क्या हम कर सकते हैं? मतलब कंट्री से बात करनी पड़ेगी या हम उनकी कंट्री को इफेक्ट किए बगैर हम अपनी सर्विसेज दे सकते हैं? भाई बेशक वो जो कंट्री है वो कुछ ना करे, हम देते रहेंगे, अतः वो बैन नहीं कर सकते।
नहीं, ये आपको अगर शायद इसका कंसेप्ट है कि नहीं है, इसको ग्रे ट्रैफिक बोलते हैं बेसिकली। आई एम नॉट हर्टिंग एनीबॉडीज फीलिंग्स, बट लेकिन जैसे नॉर्मली एक कंसेप्ट ये है कि हमारे नॉर्थ ईस्ट पंजाब के काफ़ी सारे लोग अब्रॉड में हैं, जैसे गुजर खान और मीरपुर और जेलम के लोग। तो वहाँ पे अक्सर PTA का क्रैकडाउन होता है। अक्सर आपको शायद इस बात का आइडिया होगा, वहाँ से ग्रेट ट्रैफिक के हमेशा कंप्लेंट के ऊपर वहाँ से कोई ना कोई ट्रांसमिशन पकड़ी जाती है। वो सेटेलाइट कम्युनिकेशन ही यूज़ करते हैं, फ्रीक्वेंसीज वो देखते हैं कोई अवेलेबल है। तो वो करते क्या है कि बेसिकली सेटेलाइट के जरिए यूके के नंबर मीरपुर में चल रहे होते हैं और मीरपुर के नंबर यूके में चल रहे होते हैं, आप लोकल कॉल्स कर रहे होते हो। तो अब आई डोंट नो कि आई एम अगेन आउट ऑफ इंडस्ट्री फॉर क्वाइट अ लॉन्ग टाइम। ये मैं उस वक्त की बात कर रहा हूँ जब मैं इंडस्ट्री में था, तो उस टाइम काफ़ी क्रैकडाउन्स होते थे कि लोग यूके के नंबर मीरपुर में इंस्टॉल हुए हुए थे और मीरपुर के नंबर यूके में, और आपस में लोकल कॉल्स हो रही होती थी। तो वो चीज़ करते हैं लोग, अभी भी करते होंगे और काफ़ी सारे एरियाज में चलते भी होंगे, लेकिन ये कि इफ़ इट्स नॉट रेगुलेटेड, इफ़ इट्स नॉट अप्रूव्ड, इट कैन बी ट्रबलसम। सो अगर पाकिस्तान जैसा भी कंट्री है, लेकिन पाकिस्तान में रूल्स एंड रेगुलेशन समहाउ और दी अदर, क्योंकि गवर्नमेंट को जहाँ से पैसा नजर आता है तो गवर्नमेंट वेस्ट नहीं करेगी अपॉर्चुनिटी। तो जिस तरह आपके सामने 4G 3G के लाइसेंस कितने एक्सपेंसिव सेल किए थे, तो बस में गवर्नमेंट को पैसा नजर आएगा तो डेफिनेट सी बात है गवर्नमेंट लाइसेंस सेल करेगी और मोबाइल ऑपरेटर्स लेंगे और सर्विस प्रोवाइडर्स सर्विसेज प्रोवाइड करेंगे।
सर थैंक यू।
Thank you so much, sir, for giving us your precious time. And attendees kindly fill the feedback form given in the description. In the chat, we have shared our feedback form. Kindly fill this.
Okay, thank you everybody. Thank you for listening to me and looking forward to see you guys again. Assalamu alaikum.